Isotropic material are those materials in which physical properties are identical in all reactions. For example, if we have a material which is isotropic in nature, then if you consider a point here and if you measure the physical property in the sense Young modulus along x direction, young modulus along y direction, young modulus along z direction, young modulus along z direction, and Poisson's ratio in all three directions. Physical properties means those properties which we can measure. So here, if we consider a isotropic material and if we measure the property along x, along y, along z, you will observe that all properties are same. So here Ex is equal to Uy equal to Ez, that is equal to E. If we get such type of material, if we get a material in which Ex, Uy, Ez are same, then we can say that is your isotropic material. When you say the material is isotropic, then we used to emphasize that if we consider a point, then in that particular point, we measure the material property in reaction in all the three reactions. In all the three reactions, we will get the same material property. Now, for isotropic material, we'll observe that we used to have two independent elastic constants. So here, if you see, if you write that strain and stress relationship, you'll observe that we can write in this form. Okay. Then you will observe that we have two independent elastic constants. One is your Poisson ratio, second one is your E. You also know that E is equal to E by 2 into 1 plus 2. So you can see that for a isotropic material, we used to have two independent elastic constants. Okay, so to have our stress strain relationship, we need to have two elastic constant. Okay. Now, if you consider a anisotropic material, then we can say that a material is anisotropic in nature if physical property in all three directions are defined. Now, if you have such type of material, and if you want to have our stress relationship or strain or strain relationship, you'll observe that we should have 81 elastic constant. For a ideally or fully anisotropic material, we should have 81 elastic constant. For fully anisotropic material, or you can say for a ideally anisotropic material, there is to be 81 independent elastic constant. But we may not get such type of material while we have 81 elastic constant we have. For a generally accepted anisotropic material, there is total 21 elastic constant. And if you consider a monoclinic material where we have one plane of symmetricity, in that we have 13 elastic constant. Now, if we consider a orthotropic material, then we used to have 9 elastic constant. We consider a material which is transversely isotropic, then we'll have 5 elastic constant. And now, if you consider our isotropic material, then it is to have total 2 elastic constant. So 2 elastic constant, that is your E or the mu. We also know that G is equal to E by 2 into 1 plus mu. Okay, so here if we correlate this one, we can find it. 2 independent elastic constant for a isotropic material, that can be your Young modulus or Poisson ratio or Young modulus and the shear modulus. Next, we are going to see how we can obtain a isotropic material and what are the conditions we need to consider to achieve our isotropic material from our anisotropic material. Thank you.